and Ryan did a very great job on the presentation. I don't think I can beat them. So I'm changing the topic. So trust yourself. Well, so I'm thinking about just go share some of the projects we were working on, and some of them may be quite old, but I think there are some experience, some of the something good we were doing, and something we didn't do very good. Some of these things I want to share, and just maybe just take a look what we were doing, and I think
that one.
So this is the first service view project that we started work. I think it's back on 2008 or 2009.
Maybe,
yeah. So there's quite a bit of challenge on this project. So this application, that is a not MVC, that's WPF application.
Oh, yeah.
So that's just I think about maybe 1 or 2 years after WPF been launched. So this is pretty new at that time. But the challenge for us is the application is going to run on they call notepad, not a laptop, which is lower configuration than the laptop. And the notepad is not the newest configuration, newest model in 2009. It's even a couple of years old. So it's pretty old laptop notepad, and pretty slow CPU and very slow hard drive. So we started this with the SQL Server. So we were thinking about store everything, all the data in SQL Server. That will be easier to maintain and to update. So some of the performance I think is excuse me. So we were not quite sure about the performance difference between the SQL Server versus the regular file on the disk. And the SQL Server usually for the small data, query and write, update, that's pretty fast. But for like the geospatial data, at least for us, that's pretty slow. We were trying to update maybe 1 gig of data in SQL Server, just insert into it. It took us about hours, I remember, right? Something like 7-8 hours, maybe almost 1 day to do that. That's pretty slow. And we figured are some reason about the I/O, because there's a whole bunch of I/O. Anything you are doing in SQL Server, the I/O is very, very high usage of the I/O. That slows down all processes. So later we figured, then we switch back to regular file. I'm not sure when you do the open layer street data using the post database. Yeah. How's the performance on that?
It's pretty good.
Maybe the post was just designed for something like.
Yeah, there's a package for Postgres that puts in a whole bunch of GIS tools inside of Postgres itself.
I think it's better even SQL spatial extensions, right?
Mm-hmm.
Or maybe it's much more better from what you can tell.
The tools that are in that package are really good.
Yeah, so because of this experience, and later in the other projects, so sometimes customers were asking about the SQL data. So our suggestion is do not put a whole bunch of data, especially like line in Polygon, which is pretty big data in SQL Server. But I'm not sure the newest SQL Server, how does that perform on the geospatial. But as I know, the 2012 is not that good. I tried 2006 Server 2012, it's not that good. But anyway, so even the files stored on disk, that's pretty slow, because the hard drive, that is something like 5,400 RPM. That's pretty slow. So we were thinking about to minimize the I/O operation. So like you guys maybe know, so for the shape file, so we store everything in double. For example, we have X and Y as a vertex, and we store every X as a double. and y is double. So which goes to 8 bytes into disk. So one point is going to be add up to 16 bytes. So we have some, I don't know whose idea, but I think this is a genius idea. So we, instead of store double into the file, we store integer.
Give him a new marker.
Let's try this one. So the integer goes to 4 bytes. So what we are doing is, for example, the x, which is like, let's say, 34.34567. So this is 8, 6, 9. So this is like double. So we are going to convert this to an integer. So I think we times how much? 10, maybe 10,000. 1, 2, 3, 4. So we store something like 4, 5, 6, and get rid of the rest of the decimals. 1, 2, 3, 4. I think we leave 1, 2, 3, 4, 5. We say five decimals. So the 8 and 9 is just, we dropped it. So we store this in the file. When we read it out, we just divide it by 10,000. 1, 2, 3, 4. 1, 2, 3, 4, 5. And divide it by 10,000, then turns it to 34.3, 4, 5, 6, 7. So we are losing some of the precision, but this cuts the data half, which is almost 50% enhance the I/O speed. So this work out pretty well. The only thing is you may lose some of the precision, but since most of the data was in WGS84, which if we store 5 decimals, it's going to be accurate as meter, about 1 meter. It's pretty accurate. Maybe we go more. I can't remember exactly. Maybe we go to this one, then our data is accurate to 0.1 meter. I can't remember exactly, but so this is the general idea. We just store int instead of double. Well, I would say the data that's pretty big. So this data just for one facility, one carrier for one county, which is about 6 gig for one carrier. For AT&T, I think it's about 6 gig, and T-Mobile, and they have other facilities which is about 4 or 5 gigs. And doing that just really helps on the I/O part. And also we have the disk part, the performance of the disk part is being resolved. And we go back to the CPU part, since the CPU is also pretty slow. And there are some requirements. We want the numbers or the text, what's that? Text, sorry. The text to be alignment. Or, yeah, and also we want to keep the size, relative size the same. Like this symbol, this 11 symbol, we want to keep the symbol size relative the same as the text when we zoom in or zoom out. If we are going to display so many that such label on the page, it's going to be kill the CPU. It's really slow. Render this page takes about maybe 10 seconds. So we do not do that. Instead, we convert the text into a polygon. So you can see here everything that's a polygon. We store the polygon. And we also just adjust the GDI plus settings to make sure the performance is high. We don't care about how beautiful the image is, just make it fast. So like we have some sort of the mechanism to do the cache. For example, if right now we are on this page, there's another thread in the back to cache the other tiles which is next to it. Probably user maybe use. So the CPU is gonna keep working a little while after we pen. But when users start to pen, That's just so fast. User will not notice any of the delay because of the CPU is slow. Yeah, I think there's just really a whole bunch of the performance learnings, I guess I would say learnings, especially at that time. We didn't expect SQL Server because I think we just released the Map Suite 3 in 2009, and we have a SQL Server layer. Because Microsoft was trying to say, okay, SQL Server supports the geospatial data, and this is what it's going to be in the future. So I think we are also thinking about same thing as a developer. We are thinking the same thing. So in the future, shapefile maybe just going out of our sign, and SQL Server maybe just come up. But the thing is that's wrong. So especially from this project, we know the whole bunch of performance gains from SQL Server. We do not that trust them. So, well, this project I think is just going well. I'm pretty proud of this project since later, like last year, Phil told me there's about 10,000 people, right? 10,000 people using this application, or 8,000.
I have no idea.
Yeah.
How many people? I don't think it's that many. But, I mean, they're still using it over there. to some degree.
Or the ticket, I think Phil told me something about 10,000, maybe 10,000 tickets being created every day, being created or being resolved, being using in this application every day.
Well, I know they were putting through eSketch about 10,000 tickets through the system a day, and some of those guys use this to look at what they call PLATs, which is the facility design or network data for the utilities, like the gas lines, phone lines, where are they? I don't know how high the usage is of eSketch users using the viewer here to look at that stuff, but I know that they pretty much all used to do it, and there were hundreds of techs out there.
Yeah, especially after, when we developed this, the eSketch is not that good, it's very slow.
Yeah, eSketch was still the old desktop version.
Yeah, I think maybe they just got the web edition, but it's pretty crappy.
But we didn't get the web edition eSketch till 2012. So.
Oh, I mean the last generation of the eSketch.
Yeah, it was a desktop
It's
application.
desktop, okay.
Yeah.
So I think the major use for this application was the differences between this one and the eSketch is the eSketch is trying to draw the sketch and let the manager or someone to approve it, and someone is offsite, they can see that. But this one is more giving the locator information, what's
around there.
Yeah, what's utility or what cables and pipes underground. So this is more like view it and use their paint to paint on the ground. Then use eSketch to draw the paints. They just paint.
Mm-hmm.
So and this whole bunch of multi-thread things going behind. I think it's just we learn, especially Phil and myself, just learn a lot from the multi-thread. Really a lot. We're just getting this, and there's the WPF. There's a whole bunch of the when we do that, there's a whole bunch of the multi-thread issues, even bugs from Microsoft. We just wait a new version coming out. So.
So for this one, like, how do you get the positions of the labels before you convert it to an image? To GPI+.
So we do not count. So these labels, everything being pre-converted using another software. I can't remember the name, called Unified.
FME.
Yeah, FME. Yes, use FME to convert it. And when the data, when we got the file, that is already being converted. So we do not do any of the calculation on the laptop, on the slow laptop. We just render it as fast as you can and use much thread as you can, just respond quickly.
So what do you get from that software after converted? It's an image or it's a for the label?
Geometry.
It's polygon.
That's
So
right.
everything is polygon. So you can say it's 0. I think that's
What format is it in, or what's it saved? Is it still saved in SQL Server, or is it saved on the file? It says-
Oh, yeah, we saved it into file. Since we have this file mechanism, we just rewrite everything.
It's kind of a variant of the TinyGeo format, isn't it?
Oh, that's
Yeah.
right.
So let's see. Okay, we have those three files in IDS and the IDX. So that is using the map suite 3, inherent from map suite 3. So we do geospatial query of the IDS and IDX. And those file tells us the position, the offset position of the data located in the geo file. When we go inside the geo file, which is a binary file, I think it's more like encrypted data. We have our own format, and read all the points by using using integer. So you can see like this file is like about 3 gig. If it goes to ship file, it's gonna be like 6 gig.
Oh, by the way, TinyGeo is not exactly using integer. It's like have its own way for compression. Like we use 2 bytes for an x, like 2 bytes for y, so like 4 bytes for a point. We use some other ways. I don't remember it exactly, but it's like even better than integer.
I think this came before TinyGeo, and like TinyGeo was kind of evolved from this.
That makes
Right.
sense.
The TinyGeo is a file format, right?
Yeah, it's file format. It's our own format, but it's not like using integer. It's like even shorter than integer.
Also, that's our map suite file format.
It's our like own ThinkGeo's format.
Oh, that's good. Okay,
Yeah.
great. So hopefully the TinyGeo is going up, it's going like ship file, hopefully later. And a whole bunch of people asking, oh, do you have SDK?
Yeah. So if you get data updates, how do these files get updated?
Yeah, well, that's just, we spend a lot of time to figure out the data. So there are some limitations on this geo file. So the file is a binary format, so there's no way you can remove the data from part of this file. So we can only append the data at the end of the file. It's like a shape file. So just append the new data to the end of the geo file and change the pointer in IDS and IDX, I think. We change the pointer in the IDX to point to the new data to the old one. I'm sorry, to the new one. And the old one just leaving there until user rebuild the data. So it works more like shape file edit. Every time we modify a shape file, just put new data at the end.
I see.
Even we modify one feature, we also add a new one at the end of the file. And we do not delete the original one until user rebuild the shape file. So this is working same as shape file.
Yeah, I have a question for the label. The label, why they save them as geometry? Why not save them as points? And like a pointer with a property, with a text property.
Yep,
And
that,
for the room, when you room in or room out, you just need to calculate the like room level 1, the letter A, what the size should be, the room level 2, the size should be, so we could exactly affect like your count.
yes, that's good. That's a good question. So, 2 reasons. First of all, we want them to be the exact position as no matter in which zoom label, we always want the label to be at the exact same position and the exactly same offset. The offset with the line. So position we want to be exactly the same, and we want the performance. If we do this calculation for this one, I think we were starting with that road. It takes about at least 10 seconds to render this small area. If we zoom out, it's gonna be double, even triple. There's no way to do that. So we want to minimize the calculation in memory. The calculation on the fly. We don't want to do any calculation that is to perform the CPU. So CPU is so slow. The benefit is
But you will take a lot of space if you save them as
space
geometry.
with file. Yes, that's I think that's just gain and yeah, that's just the balance.
But in this case, they were all loaded on a local machine, so it was not really a big deal once they got them there, that the file was big. Whereas in our case, we're pulling it and it's like we're downloading it.
Yeah, I don't know that.
Yeah.
And as fast as I know, the GDI Plus render the text, render the label, and it has a pretty badly performance to draw the text. I think this is a pretty good idea to draw it with the vector data.
Yeah, that's pretty, especially the text, that's pretty slow. I'm not
Yeah.
pretty slow, I mean, like, if you want to draw, like, there's at least about
Yeah,
1,000.
I think so.
Well, there's all the rules too on labeling collision and all
Yeah.
that other stuff. that
And also
the
if you,
labeler has to
and also
consider.
if you want the label to be, like, the alignment, you need to calculate the point, the center point of the label very
Yeah.
precisely. That is just gonna just greatly increase the CPU usage.
I think you can like store a library, like the letter A, so what the geometry should looks like, store it in the local. So you don't need to get everything stored in the database. We have a dictionary, then you can use the dictionary to generate what you need.
But
So
if you are trying to rotate the label, some of the label being rotated, so
We need to store the rotate degree.
yeah, probably, but yeah, probably.
Maybe it work, maybe, I don't know.
Like create a font, like your own font.
Our own
Yeah,
font.
or
Yeah.
sprite
Yeah.
kind of thing, but with vector.
So you don't need to store everything in
Over and over
from the
again.
original database.
Mm.
Yeah.
So I have
That's
to
the one.
translate the position of all those, which is calculation up front. Cause I'm assuming this ran on like the C4 tablets, right? Like those slow
Something
things we
like
got?
C4 is how, when do they use C, start using?
Well, they're Windows XP, like 1 gig of
1 gig
RAM.
rate.
I don't know the CPU, but it's terrible.
I think it's like one core.
Yeah.
Okay, that's probably C4, right? That's probably C4. They call it, at that time, they call it like a notepad.
Oh, yeah.
Oh,
So it's like, I don't know, they told me, okay, this is slow. They said, okay, I know that laptop is a little slow. And when Phil and I we were testing it, that's really slow.
That's not a little slow.
You guys are very modest.
Right now, you
A little
still
slow.
have, the search will have some requirement. They want to draw something, like, if they say or miss something, they want to draw something back to there. So if they want the label, like this one, the label, they want to draw the label back to their database.
That's
That
gonna be
is
a problem.
difficult.
That's gonna be a problem. Yeah, but if we're redoing this, I don't think the performance is gonna be that important, especially the CPU performance is not that important since the CPU performance is pretty well right now. But,
And they have C6 tablets now.
well, what about the configuration of the C6?
Let me see, they're Windows 7, it's a dual core, you know, I don't remember, I have the specs somewhere, I'll pull them up. But I mean, it's definitely better than a C4, but even at the time they bought them, it was, are they 8 gigs of RAM?
It's 4.
4,
That's
okay, so,
Not bad.
it's better.
I think it's 4. I don't remember right now.
Are they in Ben's office? I was gonna go get
It's
one.
in our office.
Okay. You can keep going, Jack, if you want, I just wanna grab those things, 'cause we've got one from here, in case anyone wants to
Okay.
see what they look like.
So this one, if we zoom out, that's even its polygon is still like 1,000, over 1,000 of polygons.
Yeah, I would say, yeah, I would say about maybe 500. If we count by the characters, it's definitely gonna be 1,000 or 2,000, I would say.
so you can then control the label to display within the zoom label.
Yeah, I think we have some of the mechanism to do that.
Is this thing, Jack? This is the
This
4,
is
it's the
not
old
bad.
one,
It looks the same, right?
and this is the 6. I mean, they look the same basically, right? Yeah. it's a little bit rough.
5104.
I think it would melt.
And this stuff is kind of expensive. It's around $2,000.
Because they're ruggedized, you know, all that stuff, that's why for the most
They
part.
kinda look like Dave's new laptop.
Yeah, kind of took the screens exposed. But, yeah, the batteries are dead. This whole thing up here is a GPS receiver for some reason.
Oh, this one, there's no GPS receiver, right?
I think it's this.
I remember they don't have, oh, yes, there are. The GPS receiver was using, there's like application called what?
Franson GPS
Franson
cable.
GPS, yes.
They still use it.
Okay. That's pretty firmer. Pretty nice application.
It's terrible. But yeah,
Pretty heavy.
yeah. They have a dock in their trucks. The guys who go out in the field with this stuff, there's like a dock, they slam it in, there's a connector here, and there's
this
a,
is for
So it's like a
It's
switch.
just
data.
what?
It's like a switch.
Yeah, it's like a switch.
So this connector is for data transfer or charge.
So put it for charge, I think.
Mostly charging because they just dock it on that. There's also an antenna, looks like, on this one.
Maybe some for,
But there's a keyboard, and so there's some data available as well, but there's a
also-
keyboard and mouse.
Okay.
There's like a little mini desk they have in the van.
Yeah, I saw the user use this one. When I build my fence, called the city hall, they sent some guys to do the marking. So this guy just do the marking after probably half hour the job could be done. Then they back to the truck. Then they do a lot of stuff there.
Cool.
Like
With this
device like this one.
Uh-huh.
So probably
Does it say 7 on it?
10
Yeah.
minutes.
Oh, maybe that's the new one then.
Do that
Yeah,
job.
this,
I mean,
Oh, well,
after
then
they
this
back
is the old
to the
one.
truck,
But
they
that
still need a
is,
10 minutes.
You'll to finish it all.
Yeah,
here.
so it's
Yeah, yeah, that's it.
I saw that.
That's good.
So we are like
This
that.
is
Not
waterproof.
the extent.
Waterproof? I don't think so. Maybe?
should be like light,
There's
light
a-
I
level
think
water.
people probably wanna submerge it.
If there's some
rain on
rain, heavy rain, it handles
It's,
that.
it's water resistant maybe, but I mean, this fan is open back
Yeah.
here.
But I mean, the difference is this
You
is
can
like,
use it as a paddleboard, the fan kicks on, drives your.
Except you'll sink when you're carrying it.
if it just rains, the rain or heavy rain, it handles that.
Yeah,
You can't just drop it in the water, no way.
Okay.
I mean, this is more using in the field, so
Yeah.
they were designed to be like some sort of water resistant.
Cool. These actually still technically belong to Certisview. They have their asset tags on them. A few months ago, they were like, you gotta give me the asset tags off those devices. We have to know where they are and that you still have them. So I had to go take pictures of the barcodes and everything.
Should have just Snapchatted it to them.
Actually, they probably like that. They have all the self-destructing email and chats and all that.
Well, they were starting using the Google Chat. I think that's pretty good too.
Hangouts?
The Hangout, yeah.
Don't get me started.
I mean, that's pretty, they were saying, okay, every password has to be go through Google Chat. There's no email, no any other sort of chat. I think they were kind of disable the history in the Google Chat, so just.
Yeah, I actually got a chat from one of the people that were doing the cadet stuff last week, and I opened up my Hangouts like this week, and I was like, oh, it's gone. I don't even know what she said. Like, sorry.
Well,
The next question is like how you protect this data you will install like thousands of instances on each laptop. So how to protect this data?
So-
Some data is kind of sensitive.
yeah, so as I said, so this data was customized design format. That's in binary, customized format in binary. So there's only our application to know what's the format, which 4 bytes that's X, which 4 bytes that's Y, which bytes that's the attribute, for example, the label or attached attributes of this feature. We were thinking about just maybe encrypt the binary, but later we think there's almost no way to decrypt the binary unless you know what exactly the format it is.
Maybe you can just consider to add one more byte after every record to yeah, that's a simple way to like encryption.
Salted.
Yeah.
Hatchet.
Just obfuscation. Just
Yeah, we were thinking about that since it's binary data, so we just let it go. And,
Yeah.
and one more thing is we are going to constantly update the data, and we don't want the update process to take forever, especially the update process is, excuse me, no. Never mind, that's something else. The data update was on the server, and the server is gonna push the data update, push a patch file, I mean the part of the file to the client, to the C4 laptop. And the C4 laptop, when the application starts, C4 laptop is gonna append the new data into this actual either geo file, IDX or IDX file. So every time when we do updates on the client side, there's no that much data download, maybe a few megabytes to download.
I did not know that's how it worked.
Yeah, that's pretty. They were thinking about, okay, so there maybe a user was in field for maybe two weeks, and they can still update the data using the cellular built-in the C4. So we just, I think this is pretty intelligence. It's more like a Windows patch file. Patch what you need. So, any other things, questions? Okay, so let's move to another next topic.
Google Drive.
Yeah. So, I think the Vermeer one is next one I want to talk about. I think they are doing pretty good, Vermeer. So give some background to you guys. So Vermeer, they are a pretty big company. They do all kinds of different machines, the agriculture machines and some of other stuff. So this is the one, the V-Sketch. So V-Sketch is using. So let me show you something about how this is gonna work. Actually, I got a video here. Let's play the video. Get more how this is gonna work.
Directional drilling is used to install conduits under obstacles such as roads, buildings, and wetlands. As demonstrated in this video,
So first of all,
conduits such as water, sewer,
may just
fiber,
use,
electric, and gas
to find
can be
all the
installed under very
utilities
busy
and
intersections
mark on the ground.
without disruption of traffic. A small area is needed to set up the directional drilling equipment. This area can be strategically placed away from congestion and business activities. Before the directional drilling begins, the directional drilling crew pre-plans the bore path to carefully avoid obstructions such as other underground utilities. The horizontal bore begins with the directional drill bit entering the entrance pit. The entrance pit is used to contain and manage the drilling fluids. The directional drilling crew are in radio communication with each other throughout the entire process. The directional drill bit is tracked by a sonde, or radio detection device, housed within its extended connection to the directional drill pipe. The depth and pitch is sent to the surface and received by the walkover locating device. The locator then gathers and interprets the information and gives directions to the directional drill operator on which way to steer the drill bit. An experienced directional drilling crew can navigate and steer the drill bit up, down, right, left, and a combination of varying degrees of each to drill a desired horizontal bore path. The drilling crew has the ability to determine the exact depth and location of the drill bit at all times. A typical mid-sized directional drill uses a 4-inch drill bit to drill a pilot bore. The bore path is typically enlarged to 1.5 size the conduit that is being installed. In this installation, the bore path has to be enlarged to accommodate the conduit, and a reamer is attached to cut a larger diameter hole. The reamer is simply pulled through the existing bore path to enlarge the hole. As depicted in this video, and as with most directional drilling projects, very little of the normal sitting activities were interrupted during the conduit installation. After the bore path is enlarged, the conduit is simply pulled into place by the directional drill rig. This method of installing utilities has many benefits that include less disruption of commercial activities, less disruption of traffic, less site rehabilitation, and directional drilling can also be used to avoid damage to wetlands, streams, and for river crossings. Directional Technologies has installed miles and miles of conduit using directional drilling over the past 23 years. Directional drilling.
Let me stop here. So like here, this cable is not, I think it's pipe or something, it's not so big. Vermeer sent us a photo. This thing, this pipe, could be go as large as like this diameter. That's pretty amazing. The machine is very powerful. Just grab the pipe all the way through. The diameter is like it's really huge.
But there are other
Directional
machines than that one you
technologies.
showed earlier, right? For the huge ones?
No.
Or is that
Oops.
still the same size machine?
The machine size. The machine size is so they have a smaller size of machine. Smaller size of machine just drill maybe smaller size, put smaller size of pipes, and they have a very big machine to pull big ones.
I see.
How big it is? Like a tank?
Well, that depends. So that depends. If we are to just install a let's say install a cable or some sort of water line, that's like this size should work. It's pretty small size. They have even smaller I saw even smaller, maybe half of this size on the site in Frisco somewhere. And the big one goes up to even bigger than the 14-wheeler. Even bigger. I saw that's one of the pictures. Huge one.
It's like one of those Russian trucks that moves missiles around.
Something like that size. Okay, so let's take a look at this application. Liberties, where we are. So there we go. So as most of people may know, this application was inherited from eSketch. We just use a whole bunch of the eSketch modules and the design. That's pretty well. I mean, it work out very well. Especially the map engine part was separated from the main application, which is really good. I mean, like when we do the OpenAir 3 upgrade from OpenAir 2 to OpenAir 3, and we spent about I think about 6 months to do the OpenAir 3 code. Before we finish, we've been pulled out from project. No that much testing. And earlier, Galen told me the OpenAir, all the bugs are pretty much related with map. There's almost no bugs related with the module, with the map and the module part connection, since we separated the map part and the core business logic. So since, I mean, like this huge upgrade, there's almost no bug on the business side, business logic. We are really impressive. That's just really good. So one of the major change, major thing different with eSketch is I think the target is kind of, I mean not the target, the things that people are concerned about, that's different. So in eSketch, people are more concerned about those utilities in the area, right? But here, so those things are just our obstacles we want to avoid. So we're more concerned about this utility line. So for example, so we are going to do a drill from here all the way across the road and to here. So we know there's a gas here, and so we have a side view. So this is a top view. From the top to the bottom, you can see everything on the ground. But we have a side view which gives you the side of this site, so which you can know what is going on below the ground. So when we draw this bore and all the green line, you can see that's the surface of the ground. And we also pulled elevation.
So you know the elevation of the surface.
Yes, we also pulled elevation from Google API, I believe. And then here's a creek. It's right here, the creek's here. So you can see there's a drop. And after the creek, that's So I think this part is higher than that, yes. So here's a quick. This is one thing. And also, we also give the depth of each of the line. So let me use this example. So this gas line, right now we have the elevation AOR. Let's give me elevation about 700 here. 700. 710. So if I give the change of attribute to say, okay, so this is our gas, and each of the point of the particle point, we can figure out the exact depth. So this could be configured either using elevation or use depth. If we use depth, it's going to be the relative depth from the ground. So user can just drill a pothole and just see where the gas line is. So we were concerned about this black line, which is the actual bore, and this yellow thing, which is the actual gas pipe. We want to avoid that. So for example, if this pipe, this yellow thing, the yellow pipe is over here, we don't want our drill path through it. We want to change our drill path to even lower, maybe just northmost patches elevation. Let's see, this one we go to 720, 730. So everything we are doing here, let's just give user. I do the wrong direction.
Higher, right?
Higher, yeah. I should go lower.
Stop our bomb.
Use just aerial suspension cable.
Let's see.
Carbon nanotube space elevator.
Cam switch.
See, we're making depth. Depth should be, let's see, 30.
How far can these things drill?
Good question.
That's pretty big. I know their video says they drill about like half mile or something.
Wow. Dang.
That's
My neighbor, he did a natural gas line in West Texas, and they went underneath the Canadian River, and they had to start, I don't know if it was Vermeer, it might have been a different one, but I think it was over a mile.
Jeez.
And they set a bucket, like, or an area with it, and it came right up perfectly where they.
Wow.
Oh.
well. I think just the technology. I would think is really amazing. People really thinking about this and doing a bunch of job. So this is for the user to preview, to know what's the depth or what's the pitch of this bore supposed to be, and they will adjust the parameters on the drill machine to say, hey, drill, go here first, then turn left, turn right, go up, go down. So this is for the preview, and that's for the first milestone of this project, and right now they are even implement even more. So like in the video, let me go back to the video. So in the video, you can see there are some workers just on the surface and detect the head, the depth of the head, the drill head, and then the user is gonna report the information back to a server, to one of the server, and our application can even pull the new data from the server and adjust the board accordingly to make this board exactly match what it is underground.
Wow.
So this is, I think that's
So
good enough.
the human doesn't even need to do anything, right? The plant or the machine just changes based upon the data it gets from the workers out there recording it automatically, or do they have to look at something and plug it in?
I think they need to adjust the machine because the machine controls the pitch or the angle of this head to where does this head go. If we want to change the position, they need to reconfigure on the machine to just change it. But their application, I think they're kind of out of date. The application running on their machine, on their machine, they have a Windows CE application.
Wow,
That's
man.
really old. Windows CE application is actually the application controls the board machine, which direction of this board head to go. And so we can generate this board first. And this board is going to tell the machine, okay, what's the draw plan. Then I'm not sure how they import it, maybe import or somehow user manually input into this machine. I think user just input each of these points. This point. They call it like, I think it's called control point. User just import those points into the machine, and then machine will calculate the actual path of the board.
Connection.
Yeah, so as here you may say there is a little red line go over the point, go over the blue line. The reason is we want this board exactly match what the actual board, there's a metal rod, right? Let me see what I'm talking about. So this is a little rod. They want the board exactly match the rod, because you using to draw from here to the outside, maybe use 10 and use 11 rods, but the last rod just has halfway out of the ground, just drill out. So where it is. So there's maybe I think this is a quarter of the rod being drilled out of the ground. This is pretty accurate. So I'm not sure how accurate in sketch is, but in here they really care about the accuracy, especially the depth and the X and the Y. Make sure this board will not too close to the gas line. So that's one thing. One challenge we have is for this. I'm not sure how to do that. How we resolve in eSketch. So this is all the way we can zoom in Google. We want to zoom in, but we can't. Earlier we were using Bing Map. The Bing Map zoom level is about the same, but Bing Map, when you can zoom in, the Bing Map just a scratch image. Not scratch, a scaled image.
Mm-hmm.
Then you can zoom in. Even the image maybe looks blurry,
Just expanding it.
but you can see that. You can very accurately control the point. But
Yeah.
here we don't have much control, since the Google Map have a whole bunch of limitations when we use in OpenLayer.
Mm.
So that's one thing.
Go back to our office. This is a pretty new aerial update of our office park, isn't it?
Ooh, this is pretty new. This is like just
Yeah, it's
few months
like
ago.
the last month or two.
This is Google?
Google.
Yeah, okay.
Wow.
Must be a weekend.
Yeah, right.
It's gonna. That's
Yeah, it's got to be weekend.
morning, afternoon.
Mm-hmm.
That's pretty nice. That's afternoon, I guess. Not afternoon.
A little before then. It's weird, I didn't realize those other buildings had a different colored roof.
Yeah, weird.
Maybe just the shed, because.
No, look at the ones on the right, not those,
Brown.
the ones up
Oh,
top.
this
those.
one up here. Yeah, that's different colors. Yep, things going on.
We've got this, another imagery provider we switch to once you get to the maximum zoom level from our first provider, which we don't use Google or Bing. We've got Digital Globe, which is kind of a similar kind of WMTS service. But then on top of the 20 regular zoom levels, we've also got like 3 more zoom levels, where once you cross this threshold, we switch to another image provider that does a single tile image based on an extent,
So this.
and then we just blow that up if we zoom into it.
Okay. Well, what's the coverage about that service? Is global or just US?
The high zoom service, I don't know, I think it's just North America.
Okay. I think Vermeer, they're targeting the global.
Well, cause I know Edgar's told me that when he's tried to load it from China, it's just white, it's like a white image is all they get, so they don't have China data. They might have some for other places.
Yeah, so they were using this. I think in US it's pretty good. I know once they show us in German, it's even better.
Yeah,
It's even
they're
better.
pretty serious out there.
This would be the perfect app for, the drone deploy too, where, I mean, you don't care about a big area, you send up your drone, you fly it for 10 minutes, you download the imagery and put it into the app, and then you got, 1-inch aerial imagery, 2-inch aerial imagery. Did I ever show you that I did in my neighborhood?
Yeah, that's pretty
Yeah,
amazing.
Because, I mean, for this, you're not gonna need much of an area, you can really get detailed in.
Well, maybe if it's one of the bigger ones that can drill over a mile.
Yeah, well,
Even not a big deal. I mean,
even a
that-
mile's not.
Yeah.
It's not big. I mean, their workspace is more like a line. Right. So do you think anything about special about this project?
How you get the gas line exactly position like
That's pretty similar with eSketch.
But this sketch don't record the deep of
The depth.
yeah.
Well, I think is as I'm not sure the gas, but I'm pretty sure about this electrical or water, because for electrical they have a device. They can hook up the device on part of the maybe just plug in, and that device is just sending messages and sending the I'm not sure how to call that tracer line something, yes. So in the electrical wires, so all the wires is gonna have that
I see.
send out. They have a device to detect on the ground. They can just divide to detect. Okay, where is the actual actual power line underground, and what's the depth? They can calculate it very accurate. I'm not sure about.
We don't record that.
I'm not sure about the gas, because I know electricity they can do this. For water they can also do, because water is like you can
Flowing.
flowing, and they can detect use some sort of like low voltage signal or something they can detect. I'm not sure with gas. Gas is more like, I think it's plastic, not like PVC.
Yeah.
PVC.
Electrics and PVC typically.
Typically.
Casing.
Oh.
Gases, I don't know.
They do some PVC and some metal for like the larger ones.
Okay, maybe they have. I'm not sure for the residential small gas line. They just have a whole bunch of ideas to do that.
If we have some like rock underground, so is there any way to around that? Or they can just break the rock?
Drill through it.
The drill, that drill, that's pretty powerful. The drill is, let me show you let me find another video that is like,
That reaming head looks pretty serious.
Yeah.
yeah. Let's see, that's pretty powerful. Drill,
Rock is not a big,
what's that?
big deal. Break it.
Have you guys seen the boring company from Elon Musk that he started?
Heard some mention about it.
Yeah,
Forget
we'll have to
what
pull up
his
the
deal is.
YouTube video after this to show you.
Boring.
That's a pretty big one. Jump a little bit.
Brian's car could still take it.
Yeah.
Maybe not enough work. I'm sure it can work that.
Like this size of this rod, and there's no drill head. This is more just to show how this machine can work.
Real time.
Demonstrating this machine. Demonstrate a drill head. Drill bit, I think. It's something like this. They even have this
Directional
diamond.
drilling makes construction projects like this one fun, where proper
This
setup
here,
and
they
advanced
even have
steering
a diamond to on top of this,
Yeah.
and just spins and any rocks, anything, just smash
Looks
it
like oil well drill bits.
like that. Smash everything.
A skilled driller can direct the course of the drill stations. A jetting assembly uses high pressure.
The tailings,
Yeah.
under there, I think they put slurry down it, doesn't it, and wash it
Yeah.
out with water?
Okay, so they're just like shooting pressure all the way through and it just pops back out at you, okay?
Yes. So here they have like to spray water here. Just
It's a coolant too, probably.
I'm not sure cooling. Maybe mostly get the soil to be mud, then just push back, push out. This thing gets moving forward.
Third connect. Back to rotating the drill
You
string.
can see here. That's the
Harbor
flow.
formations
water.
require a different approach. A drill motor replaces the jetting assembly. Now the
They have
hydraulic
nozzle
pressure is
in front
used to
of it.
drive a turbine, which rotates the bit without having to rotate the drill string. This allows the driller to orient the bend and drill in the desired direction. The string is pushed forward or slid, guided by the deflection of the bend. Once this directional adjustment is complete, the drill string can again be rotated. At regular intervals, steering data is gathered and adjustments made.
It's pretty cool.
Yep, I think like Vermeer, the guys, they're pretty. I mean, they are pretty good to work with. Yeah, I think that's. There are a whole bunch of other small projects. I think those two are more typical and more related with recent development. And this one, so we were using the OpenAir 3. I know eSketch, VSketch. I'm sorry, search the view, VSketch, eSketch. So eSketch is going to use the OpenAir 4, right? They're going to.
Yeah, because 4 is already out in full release, and so if we're gonna do an upgrade, that's what's in progress now.
The 4 is like this final production release or.
Yeah, but it's a stable full release, and it's not a complete rewrite like 3 was over 2. So they're similarly compatible, like most APIs are compatible.
That's good.
You wanna read anyway.
Yeah, hopefully we can just share most of the OpenAir 3 code with you guys. So OpenAir 3 code is more isolated in its own territory, so should be easy to, not easy, I mean easier to
Oh, yeah.
integrate.
And OpenLayers 2, I mean, when they built that, it was not really any touch event support. The touch devices were not really considered. We had to patch in a whole bunch of support for that stuff ourselves.
That's a pain. That's really a pain. Anything we want to do, any bugs or enhancement changes we want to do related with the touch, it's spent not by days, by weeks.
Yeah,
It's even the minor thing is by weeks.
yeah. Are the VSketch guys, are they using Android tablets, or what were they using?
We have all kinds of different. So we were focused on the Chrome browser.
Right.
So it's supposed to be any device using
Okay.
Chrome, and we also support the Firefox because one of their high accuracy device only support Firefox.
Okay.
That device is pretty. The GPS accuracy could be into a centimeter.
Hey.
That's pretty accurate. But that device only supports Firefox. That's an Android 4, I think. But I don't know why it does not
That's
support.
weird.
Maybe some sort of license thing with Google because that device you can install Chrome, install anything, but there's no GPS data sent into Chrome. Only Firefox gets GPS data from the device.
That's bizarre.
That's strange.
That's very strange. Seems like there's.
They did want to write down, so they wrote a Firefox extension.
Yeah, that's why, because we spend a lot of time, so whole bunch of weird bugs, problems with Firefox.
Yeah, I'll bet. We don't support it at all.
That's really crap because they just support one device and there's not that much user using that device, maybe a few, but just for that few users, and we support Firefox and spend a lot of times on the weird bugs. 99% of users will never happen for them.
It'd be easier for us to support Edge than Firefox.
Really?
And I think it would. We actually did some analysis on it. Like, yeah, we can get to Edge if you guys really want. Firefox, please do not make me look at this.
Oh, I forgot to mention that. So one of the things, the major change with eSketch, with eSketch that the update mechanism is different. I think in eSketch, every time you load up the application, it checks the server if there's a new version, right? If there's a new version, then we download it.
Yeah, it uses the old HTML5 app cache.
Yeah. So we are doing something.
You use service workers?
Yeah, we use service worker. So every time user launch up the website, we check to see if you have cache. If you have, we just launch up. If you don't have cache, we load from server. After the application being loaded, the user is using, we have a background what they call service worker.
Yeah,
In the
so-
background, it's checking the server. Okay, do you have new versions? If you do, just download it
In the background.
in the background.
Yeah.
And next time when user open up the application, we check to see if there's a new version. If there's a new version, we pop up and say, hey, there's a new version. Do you want to upgrade now? User can say, no, I want to use the old one. Then we use the old one. Until user says yes, then we update. We just reload the page,
Right.
which is more. I think it's more user friendly and efficient for user.
We added support for that in eSketch too. We're not using service workers yet, really actively. I think it's a toggle you can switch over to it. The eSketch user base is a lot more tightly controlled. I mean, whereas Vermeer's guys are just out there using it in a fairly normal sort of way. Utiliquest has got those hundreds of techs using those tablets, and they really want like down to the second control over everything that they're doing. And they don't want them to do stuff they're not allowed to do or shouldn't be doing. So giving them a choice of when they wanted to update, I mean, that'd be like president of Utiliquest would tell me to get out if I suggested that. But if it was able to happen in the background without interrupting them, that would be nice. So eventually, we'll try and get to that, because we have the functionality, just they refuse to take any updates because they're paranoid, so.
Yeah, we just did the internal test.
Yeah.
We have not go to official
Lord.
QA process.
Yeah, I think that should be pretty. At least if I'm a user, I would like that.
Yeah, I'm like, yeah, I would too. But there are users of, they don't have a very good working relationship, some of them, with the company. Some of them will go out there and like draw the same gas line 5 times, because they get billed, they get paid by the foot. So like, well, it's 5 times the footage, and they only see one, and so then they had to build all kinds of analysis to detect that, and so it's like jailers and inmates almost in a way.
Those people are smart.
It's also crazy because like the vehicles that Utiliquest goes out has cameras inside of them too, and those cameras actually like measure how far away they are from other cars, and like if they're too close to a car, they're speeding or whatever, there's like a light that will turn red, and like a voice will come out of
Yes.
the camera and say, no, you're going too fast.
Yeah, it tracks their eye position too, doesn't
Yeah,
it?
it
Like
does
their
some
eyes
really
waver.
crazy things that
Yeah.
like it detects if you're eating food or drinking in the car while you're driving.
Yeah.
It's,
I've seen footage where the guys are like cursing back at us, shut up, shut up.
You haven't seen the footage of it?
I've seen a little bit of it.
yeah,
He's looking
like
at it
where, yeah,
recently.
I looked at it a couple days ago, and like every time there's an incident, whether that be speeding or a wreck, they record like 20 seconds before and after the thing. And there was one that they showed where it was a parked car. The car was parked, and somebody else backed into the car, and they blamed the driver on it because he parked in a bad spot.
So you can see how these sorts of relationships form. It's
It was
adversarial.
insane. Like
There's nothing the guy could have done.
like looking at the camera, like he was parked along the curb just right. It looked just fine. It was really just this woman in some SUV that just went right into it.
And they blamed him. Excellent.
Like,
Okay.
and like the guy that was presenting all this, he was like, yeah, and we had to tell him, we parked a bad job and blah blah blah. He was like,
What was
What?
it supposed to be?
like he had no control over that. Like, anyway.
I kind of slowly understand why they are. I mean, they're just slow. All kinds of things they need approval, they need
Mm-hmm.
permission, and
Lot
go
of-
through all kinds
lot of
of
red tape.
Well, they have a lot of compliance issues, so, I mean, SOX compliance, where they're having to adhere to certain standards of things, and then the business
Trails.
utiliquest with the location of these gas lines, that's like liability for them, because they use their sketches to determine where those lines are, then construction goes out, hits a gas line. Well, then they gotta go present all the evidence, like, oh, we located it and all of this, so. I guess there's a lot of writing on it, like there is here, I suppose, but Vermeer seems to have a better working environment from what I hear.
Well, they just sell the machines. I
Oh,
don't know.
okay.
If somebody bores into something, I wonder who is liable. I imagine it's the
Probably not
operator.
Vermeer. They just made the tool, dude. Yeah, that's kind of who you wanna be working for.
Yeah, all right, I think that's pretty much for this sharing. Thanks for everybody's join, and
Thanks, Jack.
Yeah, good stuff.
Thanks.
well, I mean, like, I was thinking about how there's a whole bunch of small things, small projects. Some of them I just can't remember, so it's too tiny.
Yeah, you don't hear about lost my doggy and device listers and things like that.
You could have pulled up GeoPlan, now you're on
Oh,
for a long time.
yeah.
I skipped that because I want to talk about that. Just I can't set it up. I can't show you that.
Couldn't see it
And
before.
I tried to register a trial account on their website 2 days ago. There's no response, so I can't show you guys. So just skip it. But I would say, but I'm thinking, the GeoPlan is kind of our, I think, the first official web API project. We were starting from ASP.NET, then go to JavaScript, then go to web API. And that is transaction of this project in our, at least in our professional service team.
Thanks, Jack.
Cool.